for infill optimization earlier. We can do something very similar for metals as well, using different kind of printing parameters. Like we said before, we have some limited CAD ability in the software. So here I've actually used a plane to slice this, or to cut this part into 2 halves. And with some different slicing settings. So if we combine those 2 halves, you can see that we have this kind of weaving and contour combination. But due to the nature of the multipliers of the weaves that we've used, we've got a gap here, and there's also a gap here. So similar to what I've done before, I can filter these different areas, and I can actually, in this case, extract like the very end of that weave, and I can move it along and make it thicker. So if we do that for this section as well, the other weave, and combine that with the weave, and then let's take a look at the final result, I believe. Yep. You can see now that we've thickened this particular bit up, and in WireArc Additive, it's not usually the case where you change parameters like dynamically based on speed and thickness, like you can with a polymer extruder very easily. Just change the RPM, sequence it, or synchronize it with the speed of the robot. Usually you're a lot more fixed to a set number of parameters in WAM. So either here we could give it a different welding parameter, or in our toolpath operator for these kinds of technologies, instead of having a dynamic extrusion where we can set different speeds for different kinds of line types, we can set a constant rate of deposition. So we know how much material we're depositing at a fixed rate. The robot or the gantry will then go at the speed that is needed to deposit the correct amount of material. So point being, we go at a constant speed for this section, and then for this thicker bit here, we move slower. And as we move slower, deposit more material. So we can fill in these kinds of gaps nicely. We can do other things as well with regards to optimizing for like stress or thermal buildup. So here, for example, we can filter by every nth layer again, reverse the direction, combine it. And what that means is your stresses as you build up, they won't be, one directional. We can kind of try and cancel them out and keep the part a bit more steady. We can also add extra material. We can compensate for slumping, things like this. There's lots of different tools and tricks and hacks in the software that you can do to really get the most out of your challenging technologies.